Here I've made my kind of amateur operating system that mimics the behavior of a command line. And you can try to say hello, but it's don't like that. It's sensitive, case sensitive. Oops, I don't like. I don't like a call for help either. Yeah, but it does recognize a command, you know. So I could start adding more functionality in there, a whole list of commands that it can recognize, and different types of responses of various levels of complication, you know, to extend my command line. However, let's go have a look at our binary here. Okay, so just that little bit that I've done takes up this much space, and we only have that much space to work with, so that leaves us about that much. So clearly, even if we were to extend the functionality of our keyboard driver, once we have that, we have no room left for a program to speak of. How do we circumvent that? Well, in the next exercise, we are going to learn how to jump out of our limited boot sector and into a much more vast world using a kernel. Okay, oh boy, that sounds complicated. So just to get started, let me start very simply. I'm just going to wipe out everything here and test for. I'll do it this way. Save as, and let's see, in here alongside test, I'm just going to make a bootloader with the appended extension. Good. There. Okay, now I'm in bootloader. Now I can wipe everything out and just recycle here. That saved me typing 2 whole lines of code in that time. So in there, let's just keep it simple. I want to do something with the teletype and print something to the screen. How about just an A for proof of concept, and then we'll int16 it. Yeah, it looks good. That's about all I need for the moment. Let me save that, and yeah. So just to verify, I can close that, go over here, and just NASM my bootloader. Well, I could have kept the keymeal part in there. Hang on. Let me do that again. What? NASM, and just change that to here. Oh, I see. Bootloader, yeah, and then yeah. Bootloader. What? Hang on, I left something out of the equation there, unfortunately. Test, there's what bootloader, there. Now what do I get? There, okay, so it prints an A. Okay, so our bootloader is Trepahondo, great. Now I'm going to go ahead and create a new file, which will be my kernel.asm, I guess. And it'll be at a new origin. Okay, so hang on one second. So let me go back to my binary here. Okay, there's my file. Okay, so essentially I want to jump, there's my bootloader. I want to jump from here to here. Okay, well, here is down here. It's one place after here, right? And it's here. I can't click on it because there's nowhere to click. Okay, but So what is that? That is this plus 512 bytes, right? Here, let me just, I'm going to copy that and head on over to my calculator. Make sure you're, if you're in standard mode, you want to make sure you are in programmer mode. There you go. Go to hex. Yeah, go to hex and paste there. Okay, and then what do we want to add? 512. So let's just go to decimal and say plus 512. Wow. And then equals, and there's our hex number, 7E00. That's where we want to jump to. Okay. So can I just copy that? Yeah. Copy. There. That's nifty. Yeah. Click there. Okay. So, and then that means my kernel can start at there, 7E00. That would be OX there. Okay. So it will start immediately after our bootloader. And let's just also do the same thing. We'll put some verification in there real quick. Say 14. Tab. Yeah. Move into Al. We'll put a B so it doesn't print the same thing, signifying it's a different file. Okay, int 16. Okay, sounds good. We don't need the magic number on here, because we've already booted using the magic number. We're active. So here I'm just going to end the program. Yeah. Just in case. Okay, so we should be good to go. I need to save this as, we'll go save as in the same folder, chaos, paste, not as a text file, no, as an assembly file, kernel.asm, inc. Okay, good. That is good to go. Okay, so our bootloader has this in it, okay, and our kernel has that in it. So obviously I can boot one, the other won't boot, it doesn't have a bootloader on it, okay. But still, how do I get from here to there, right? Okay, so, well, to make a long story short, I guess, let me just copy and paste all this to make that long story even shorter. Okay, so there's the stuff that you need to bare bones minimum jump using assembly. There are all kinds of complicated YouTubes on how to do it in other languages to get from into protected mode, which is a marketing term for 32-bit, or extended mode, which is 64. You got, and then in order to get to 64-bit, you have to go to 32-bit first, and then jump there. Oh, just God, boy. Okay, so speaking of jumping, we need one more line here. Once we've loaded all these numbers and stuff. To 0. It's all good. I'm curious, what is in hex? What is that? 19. Oh, of course, right. 19. There, consistent. So this will this is like the old school, like back in the old days, all you had was 512 memory on your computer. So in order to get out of that, it assumes that you're jumping to another external hard drive or something. See, so you have to define all these. Oh, what drive is it, and how many sectors, and which cylinder? You know, all this old school stuff. You know, I don't think any of this is hardly any of it is necessary in today's solid state digital hard drives. But the computer still expects it at this lower level. You know, so there you go. You got to have all these numbers in there, and then once you do, you are free to jump to your destination. And I don't know if there's another way to do this or what, but I'm just gonna well, you can't say by the book, because this is one of those go figure it out yourself flipping kind of things, you know what I mean? There, jump to an address, this address, okay, which is where our kernel resides. Okay, so hopefully this will, it should print at that A, and then jump to an external file, as well as another place in memory, if all went well. Okay, let me just save that. Okay, so now if I might go to my snippets here. So yeah, you can just run NASM on your bootloader, right? And then run NASM on your kernel, or you can just do both at the same time, like that. There, it did it. I love how it doesn't say successful or anything. It just, you know, oh, did it happen? I don't know. Okay, but anyways, okay. And then the next command here, a new one, is cat. Okay, that is Windows way to concatenate. I'm going to copy that and then put that there. There. So now the bootloader dot the binary, bootloader binary, and the kernel binary have been combined into a single file called combined binary. Okay, so now we can just go ahead and run QEMU normally, you would think, but no, you want to add this minus FDA tag, so it's federally approved, I guess, Food and Drug Administration, and yeah, here, that tells it that it's okay to run two files that have been combined, I guess, I don't know, something like that. There. So it prints our A and our B. Hey, signifying that our first program loaded, and then spoke to the hardware and said you do something in the teletype, and then the other one loaded. So now we are outside of the boot sector and in a whole new segment of memory, and then it used the same teletype and printed a B. So we have verified that both halves are functioning. Wonderful. So, I mean, I could wipe out the screen because technically we're not in A anymore, you see. We're in a whole new sector, no longer limited to 512 bytes. We are limited to the amount of RAM you have on your computer. And if you're running Windows, or capable of running Windows, you got what, 4 gigabytes? Well, that can go a long way in 16-bit, let me tell you. Okay, so that is that, you know, if you just need that information, and end of lesson. However, let me see. I want to move on to, let me go back to my bootloader here then. Okay, so there, we're jumping, there's all the instructions, everything wonderful. Okay, and now I would like to, instead of printing to the teletype in glorious black and white, I want to do something a little bit more colorful. So I'm going to use a little bit different mode of printing text than using the standard teletype. I'll just paste my entire program in there now. So here, now I have a message. Press any key to continue. I'll start from the top. Clear the screen. yeah, bootloader, where a good bootloader should be. This is where your hardware is going to look at this address normally for your bootloader. Why not at 00? Well, the computer itself, the hardware, needs some space to run a few things, so it loads that at the beginning, and then you can come in later on down the line. Okay. Hide the cursor. Okay, prepare the pointer, video, welcome message, wait for key. There is our kernel-y stuff. A little bit of, in case it doesn't work, it'll print an error. Nifty, yeah. Okay. So anyways, here, I'm using a different method of printing the text so I can get colored text, right? I got a limited amount of space, 512 bytes, right? But I picture, how a BIOS works. Maybe you do, maybe you don't. Where you basically, all you can do is scroll up and down with the arrow keys, and it will select from a number of choices on the screen. And when you do, the background of the text changes color or something. Well, I can do that now in mode 3. Let me see here. Mode 3, graphics mode. Where do I define my color? Actually, here. Color attribute here. If I go OX AB32, then AB32, then the first part of the will be what background color, and the second part will be the foreground color. I forget, one or the other, but so now we're working in at that level. See, so that will allow me to make it so you can scroll through a limited number of choices immediately. See, I wanted a program that just boots, bang, the moment it starts, instead of having to sit there and wait for a bunch of stuff to load. Well, normal computer kind of does that, but then it hands you over, and you have to load. You want to just jot down a message or something, and you got to sit there and wait while it's loading Taiwanese language modules and JavaScript and Python and every other thing under the sun that you're not really going to need, and maybe you're in a hurry, and so that 4 minutes that it takes for all that to load, is like 12 days, right? So I pictured a operating system that uses a state machine, which I described the structure of a state machine in one of my early tutorials here in the series. So from the bootloader, well, it'd be similar to a grub bootloader, I guess, where right away you have a choice of options, but instead of booting into one operating system or another, you could boot into a different state, right? Like if I want to be in email mode, there's only certain things that I need, or if I just want to do some text, I don't need like all countless things loaded in the background, so that allows you to quickly, load whatever program you want from the start. You can, it can load into a default mode, or you could jump immediately to whatever state you want. It will immediately load just what you need, and then it can quietly load whatever else it wants to in the background, as long as it's not getting in your way. That was my priority. I figured that would make a much faster operating system that does what you want instead of making you wait for what the programmers wanted all the time, right? Okay, enough said. Okay, so what I have, let me save this. Again, I have to, here, we'll go observe here. Also, here I can do all of this on one line, and then I can do that, and then I can do that. But if I start down here and select all of those and copy that and go bang, it goes through all three of them at once. Bang. Okay, there's my program. Welcome to chaos. Press any key to continue. Boom. Okay, and the W turned to a B. Okay, indicating that my second program took. Okay. Oh, great. Okay, so that part is functioning. Now let's make an actual something a little more programmy over here in our kernel now. First thing, why don't we just clear the screen, I guess. So we want to just say mode 3, video mode 3, and then do it. There you go. There you go. Good. And then I'm going to just define a main. Like that. Good to go. And then we can say GIMP main there. And then let's see, in our kernel, we could, hey, we might as well just use that keyboard driver that's in the same folder from earlier. Yeah. I will say include our, unfortunately, it doesn't recognize the external file and write it for me. I have to type it myself. Keyboard driver. Well, you can see we're using shorter names. Comes in handy. Ink. There. Okay. There. That is all included. Now all we have to do is point to something that's in there and call it, such as our. Oops. We can. There's a read key, I think it's called, and also then we can print whatever is in our in memory in whatever's stored in AL will be print when we call our type program or subroutine that's located in here. Okay. Bootloader, kernel. So technically there's 3 files associated here now. Bootloader, kernel, and keyboard driver, right? But all I need to do is assemble these 2. Yeah. Because this one here will automatically be assembled along with that one because it's an include. Okay. What am I looking for here? I want to NASM the bootloader and kernel and do all of this stuff. So I'll grab that, head over there. Welcome to chaos. Press any key to continue. Boom. We are in our program, and now I can enter stuff. I can do capitals, I can do numbers, I can do all kinds of nifty stuff. There we go. So my program is running from here. I'm using a different method here of keyboard driver than I did in the previous hacked command line thing, but here I can start building that up again from scratch and make it more effective and efficient, But there, got my foot in the door. I am booting into my program, using a bootloader, boots into the kernel, and then the kernel can also load includes. So that allows you to, where is there's my kernel. Okay, there. So you can define a whole bunch of includes here, and then now that's in a nice separate file, right? See, I could go open my keyboard driver. There it is, and update that over here. See, and it keeps everything kind of nice and compartmentalized, and then it's easier to organize. All I have to do now is focus on my code and my program, and things that I've already put behind me can be kind of just archived, and you can focus more on what it is you want to do. There you go. That is bootstrapping the kernel.